Oh, good evening, everyone. Tonight's video is about adding and subtracting decimals. Decimal is very similar to a fraction. The biggest difference being it's measuring distances, amounts, not in just any specific denominator, but rather in very specific ones, tenths, hundredths, thousandths, and so on. Now, for fifth grade, tens, hundredths, and I introduce thousandths, but the kids love it because in truth, when you get to where you're adding and subtracting decimals, the truth of the matter is you're really following the same rules you used when you were adding and subtracting whole numbers. So we're going to look at some samples tonight and want to really point out, I guess the biggest point here is that when you're adding and subtracting decimals, what really matters is the decimal point has to line up because it all comes back to something we talked about in a much earlier video on place value. So place value is where we really need to start. So here's a definition. So that's a definition for place value, and place value is very important when we're adding and subtracting decimals because if the place values do not line up, it creates an issue of value. If I have a number that's in the ones place, like 2, well, that has a value of 2, but if I've shifted the decimals over and I put the number 8 underneath that 2, and let's say that 8 was in the tens place, well, that's not really an 8, that's an 80, which I just gave a value of 8 because I put it in the ones place. So it is very important these decimals line up. I'm trying to really get that across to the kids. The other nice thing is once the decimals are lined up, the adding of decimals is no different than the adding of a whole number. Because in a whole number, if you end up with a sum, that's the answer to an addition problem. If you end up with a sum that is greater than 9, so 10, 11, 12, in other words, a two-digit sum, then what we learned way back in first grade was you have to carry that new value over to the left to that next place value. Because let's say I'm adding 4 and 7. Well, 4 plus 7 is 11. Well, that 1 in the 11 does belong in the ones place. But that extra value, that extra 10, that is now a value that gets carried over to the tens place as 1/10. And that's the beautiful thing about adding decimals. You really aren't fighting this issue of like fractions where you're trying to figure out, okay, well, which numerator and denominator do I need in order to make this subtraction or addition problem work, or am I going to end up with an improper fraction that I now need to simplify? With decimals, you don't run into that. So let's take, for example, and the beautiful thing is with addition, you don't have to have necessarily two values you're working with. In this case, I'm adding three values. I'm adding, whoops here, got to get used to it again, 8 tenths, 2 and 7 tenths, and 1 and 65 hundredths. Now, what I've showed the kids to make this a little easier is, and calculators are guilty of this, because when you add numbers on a calculator, if you end up with a 0 at the end, the calculator will drop the 0 in the decimal. The reason it's doing that is because it's recognizing an equivalent fraction in the decimal. 8 tenths as a fraction would look like this. And this is where knowing your fractions actually does help with decimals. 8 tenths is a fraction, looks like this. Now, when we were doing fractions in the last chapter, we said, okay, you can make equivalent fractions by multiplying the numerator and denominator by a same value. Well, if you think about it, decimals are dealing with values of 10. So if I multiply that 8 tenths by 10, this is really cool. This is where everything we've been doing in the fractions kind of culminates in the decimals. An equivalent fraction of 8 tenths is actually 80 hundredths, which would be this 8 right here with a 0 on the end. So if I need to add a 0 to it just to make my adding a little easier, because I'll have a column with all the values in it, I can do that. The same with that 2 7/10. I can make it 2 70/100, but not change the value. Essentially, I'm creating an equivalent fraction. So now my problem looks like this, and that really cleans it up for the kids if they can just add those zeros onto the ends of the decimals so that when they go to add, they have numbers to work with. Because essentially a blank spot in the decimals, it really stands for 0. We don't want blank spots if we can avoid it. So I have the kids write the zeros in at the end so that everything lines up. Well, after that, the adding is pretty straightforward. I'm going to take 0 plus 0 plus 5, and of course, 0 plus 0 plus 5 is 5. That's 5 hundredths. Then I add 8 plus 7, which is 15, plus 6 is 21. So the kids are going to be getting practice now with some old skills. We're kind of going back to adding and subtracting. Now, with 21, that is a 2-digit number. We can't put 2 digits into one place value. The largest number you can have in a place value is the number 9. So when I get 21, something's going to have to be carried. The 1, which we see right here, is really 1/10. It's the number that's going to get left behind. It was the smaller number in that 21. Not because it was a 1, because of where it was located. In the number 21, it was in the 1's place, and the 2 was in the 10's. The 10's is always going to get carried. So the 1 stays behind, and just like we learned in 1st and 2nd grade, we carry over to the next set of digits to the left, the higher place value. In this case, though, it does skip over the decimal, and that's perfectly fine. Because when I said 21/10, if you think of that like a fraction, which, again, I said, it's nice that we did fractions first because you can use that when you're talking about the decimals to show what's happening. 21/10 as a fraction, the kids now recognize as an improper fraction. We would say, well, how many times does 10 go into 21? And we'd say, well, it goes 2 whole times with a remainder of 1, and the object's cut into tenths. Well, as a mixed number, that looks just like that, 2 and 1/10. Now watch, here's the cool thing. 2 is my whole number 1. Look where the 2 went. It went into the whole numbers. The 1/10 that I have left over, look where it stayed behind. It's staying right here. And that's good. That's what we really wanted. That's because I was in the tens place. Now, if I'm in the hundredths place, I'm going to be dealing with hundredths, not with tenths. But it's still, it gets, oops, I'm sorry, always turned around here. It gets carried always to that left. So this 2 now is a whole number 2, which gets added in with the other whole numbers. 2 plus 2 is 4, plus 1 is 5. Now, here's the danger. Here's what I really try to warn the kids. You've lined up your decimals. You've lined them up for a reason. That is a place value holder. It's saying everything to the left of the decimal is a whole number. Everything to the right is going to be a fraction or a decimal. If I'm not paying attention, though, look at what I get as an answer. Now, we as adults and kids understand this too. With money, if I'm adding 80 cents, $2.70, and $1.65, it's not $515. Well, what we didn't do is we didn't bring that decimal straight down. And that decimal needs to move straight down. Now, when we get to multiplying and dividing, there's other rules because they are different forms of operations. But for adding and subtracting, we're dealing strictly with place values. That decimal comes straight down. 5 and 15 hundredths, we would say. So that's adding. And if the kids remember the commutative property said you can put those numbers in any order you want and still add them. With subtraction, the rules are a little different, and that's going to be video 2, where we're going to then look at the rules for subtraction. Overall, though, both operations are very similar to their whole number operations. With the decimals, you're just now dealing with a decimal that has to be brought down to hold all those place values in check. So our next video is going to be on subtracting decimals.